Good evening, ma'am. Tonight, I am going to discuss a topic that is crucial to ensuring the safety and quality of many of the food products we consume daily, which is the metal can defects. A can's ability to provide safe, edible food can be affected by many different defects that can occur during its production, from manufacturing and filling to processing and handling before it is consumed. So here for our first can manufacturing defects and metal plate manufacturing, one of the issues is the laminated plate. This defect involves the separation of the metal plate into two layers that were not properly bonded during the rolling process. This is a serious defect because the separation weakens the can's structure, making it prone to failure, and it can compromise the can's ability to maintain a hermetic seal, leading to spoilage. So, as you can see in the picture here, it shows a line. This one in the picture here, it looks like it has been cut, and the other ones are separated into two layers. The next defects for metal plate manufacturing is the pinhole. This refers to holes in the metal plate originating from the rolling mill, varying in size and shape. So, pinholes are serious as they create a direct breach in the can, allowing microorganisms to enter and contaminate the food. The fact that they can enlarge during can manufacturing or processing makes them particularly dangerous. So, this type of pinhole, during the rolling process in a mill, so the foreign particles can get trapped in the plate and fail to bond. So, if these particles are large, they'll extend to both sides of the plate. Later, when the plate is used to make cans or flex during retorting, these particles can dislodge, leaving holes or pinholes in the plate, as what you've seen in the picture here. So, this is the example of this defect. So there are holes in the cans, and it is considered as a serious metal plate defect because it can lead to spoilage. We have another can manufacturing defects, a coating application defects. One of the issues is the foreign particles in coating. These defects, it appears as a dot or black spots, usually black color on the body wall of two-piece cans. This suggests that during the can manufacturing process, particularly the drawing operation where the can body is formed, some of the coating material might get charred or become ash-like and then redeposit in the surface. This is classified as minor coating application defects. This implies that while it is not a critical structural failure, it is still the quality and appearance of the can. One of the common sources of this, the coating ash or charred particles of coating, or the dirt or other fine particles that may be adhere to the wet coating before it is mixed. Another coating application defects is the coater drip. So this coater drip, typically manifesting as a solidified droplet of coating material on either the interior or exterior of the can. These drips can often present themselves as tiny, hardened metallic-looking bubbles, or sometimes leading to misidentification as a scrap and dye defect, which originates from physical damage during the can forming process. Initially classified as a minor imperfection, but it is considered a serious coating application if after a thorough examination, or it potentially involving the removal of the drip or even opening the can might reveal a more concerning underlying issue, such as a hole or corrosion of the can's plate. The primary cause of coater drip is attributed to irregularities during the coating application process, specifically drips or splashes of the coating material. So in this picture provided in the upper right corner, this is the example of the exterior part of the can showing a hardened metallic looking bubbles. This is considered as a minor defect. And in the left part in the bottom corner, so this is the inside view of what A looks like. So it is considered as a serious coating application defect because it is inside in the can. So it might be that the product might be damaged or can lead to spoilage because of the holes or the plate corrosion that is harmful to the health of the consumer. We have another type of can manufacturing defects. It is a can body manufacturing. Specifically, its defect is acid salts corrosion, one of its defect. It represents a serious defect specifically in 3-piece can manufacturing. This issue arises from acidic residues that remain on the outside of the side seam area of the can. These residues initiate a process of rusting, compromising the structural integrity of the seam. Furthermore, a deposit of salts can also form on the inside of the can, indicating a broader contamination issue. So the primary source of this corrosion is traced back to the solder bath used during the side seam welding process. If this bath is charged with acid crystals, a practice intended to keep the solder roll clean and metal tinned for better soldering, residual acidic compounds can be left on the can. So this serious defect directly threatens the can's hermetic seal, potentially leading to leakage, product spoilage, and even food safety concerns. This stringent control over the soldering process, including thorough rinsing and neutralization of any acidic residues, is paramount in preventing acid salts corrosion and ensuring the quality and safety of the 3-piece can. Another type of can body manufacturing is the malformed or incomplete abuse bead. So this defect is a serious in 2-piece can manufacturing where the abuse bead, a feature designed to provide structural integrity, is misaligned or incompletely formed. This can result in the metal plate being abraded or the can surface is being rubbed or scraped away. It is creased or dented to varying degrees. So as you can see here in the picture that we've seen here a severe crease or dented of the metal surface, and we have also here the abraded, the ones that is being scraped away. So the surface is being scraped away. So this defect arises when the can slips during the beading operation, leading to an incomplete bead, or when the can misfeeds as it enters the beading machine. If the metal plate is deeply abraded or creased, this defect is classified as serious, compromising the can's structural integrity and potentially leading to failure. Another defect here is the open weld. It is a serious defect in can body manufacturing that occurs when the side seam weld band is incomplete or parted. This defect is classified as a significant weld failure because it compromises the structural integrity and sealing capability of the can, which can lead to leakage, contamination, and ultimately product rejection or recall. Open welds typically result from a variety of manufacturing issues. One of the most common causes is incorrect side seam overlap, where the edges of the can body are not aligned properly before welding. Another frequent source is insufficient current during the welding process, which prevents the metal from fully melting and bonding. Additionally, defects in the body blank material itself, such as damage or inconsistencies, can contribute to weld failure. Tapered side seam overlap, where the overlap varies in thickness, can also cause inconsistent welds. Lastly, cold or weak welds, which result from inadequate heat or improper welding settings, are critical factors in open weld formation. So visually here, open welds can appear as gaps, splits, or poorly bonded areas along the seam as illustrated in the image. So these weak points are not only a structural concern but also a hygiene and safety risk, especially in the food and beverage industry. We have a defect here in can and manufacturing. Its defect is incomplete curl. So this defect occurs during the manufacturing of can ends. It's characterized by clips or cuts in the rolled edge of the end, known as the curl, which results in reduction of the overlap necessary for a proper seal with the can body. The severity of an incomplete curl is determined by the extent of this reduction. So if the curl is reduced by more than 0.5 mm, it is classified as a serious can end manufacturing defect, posing a significant risk to can's ability to form a hermetic seal. Conversely, if the reduction is less than 0.4 mm, it's considered a minor defect, and the primary cause of an incomplete curl is often traced back to a misfeed of the metal plate under the die during the end forming process. Ensuring accurate and consistent feeding of the plate is crucial to prevent this defect and maintain the integrity of the can end. We have here another defects in can manufacturing. It is called as a wrinkled curl. It is defect encountered during the manufacturing of can ends, characterized by wrinkles forming in the rolled edge or curl of the end. So these wrinkles can lead to an incorrect curl thickness or even create openings in the crucial double seam that seals the can. While a certain degree of wrinkles might be inherent in the can and design according to the manufacturer's specifications, it's considered a serious defect if the wrinkle is severe enough to impede the formation of a proper double seam, thereby compromising the can seals. So, the primary cause of this defect is typically a faulty setting of the curler mechanism in the manufacturing equipment. Another can manufacturing defects in double seam is a broken chuck, which is one of its defects. It is identified as a serious defect occurring during the double seaming process in can manufacturing. It is described as a section of the double seam that hasn't been properly ironed out. This lack of proper forming is attributed to a void or insufficient tightness in the chuck lip of the seaming machine. Visually, this defect manifests as an irregularity on the countersink wall of the seam. The primary cause of this defect is typically a cheap seaming chuck, which can result from a jam up in the machinery or an improper setup of the seaming equipment. Due to the absence of tightness at the point of defect, a broken chuck severely compromises the integrity and the hermetic seal of the double seam, making it a critical issue that can lead to leakage and product spoilage. So therefore, maintaining the seaming chuck in good condition and ensuring proper machine setup are essential to prevent this serious defect. Another can manufacturing defects in double seam is the key tab seam to inside. It is identified as a serious defect occurring during the double seaming process of cans equipped with a key tab opening mechanism. So this defect describes a situation where the key tabs, as you can see in the picture, the ones here, which is meant to be accessible on the exterior of the can for opening, becomes inadvertently seamed to the inside of the double seam. So as a result, the key tab is not visible from the outside of the sealed can. Upon opening the can, the tab becomes invisible on the exterior, often accompanied by the V's or tears on either side of where the tab should have been located externally. Its common sources misfeed of the end to the double seamer, meaning misfeed of the end signifies that the can's lid was not correctly positioned as it entered the double seamer. So the machine responsible for creating the airtight and secure seal. So this improper feeding can lead to a range of seam defects, including loose or incomplete seals, sharps or uneven edges, and ultimately the potential for leaks or contamination. Conversely, if the key tab is damaged prior to seaming, meaning before the lid is joined to the can body, it can also cause significant problems. Bent or broken, misaligned key tab, or a loose rivet can not only hinder the consumer's ability to open the can but also interfere with the seaming process itself, potentially resulting in a compromised seal in the area around the damaged tab. Paneling is also other manufacturing defects. It is identified as a serious manufacturing defect typically observed in larger size cans. It is characterized by a permanent distortion or collapsing of the can body, appearing as flat, vertical panels or indentations as what you see in the picture. This severe deformation of the can body is considered serious if it reaches a point where the internal coating is fractured or the double seam or side seam is damaged, compromising the can's integrity. There are several factors that can contribute to this defect, including the excessive closure vacuum created during the sealing process, the excessive external pressure exerted on the can during processing, and the excessive pressure experienced during the cooling phase after processing, or the use of inadequate plate gauge or temper in the can material. We have another can manufacturing defects. It is overfill, flipper, springer, and swell. So let us identify these four. So overfill, so from the word itself, it is there is no extra space or the head space for the product to expand a little, and overfilled can is similar, it's packed too full, leaving no room for the contents to expand due to temperature changes during processing or storage. We have swell or soft swell. One or both ends of the can are bulged out, but if you press on them with your fingers, they might give a little indent in. Usually, this is a sign that tiny little critters or the microbes have gotten inside and producing gas as they grow and spoil the food. We have also hard swell. Both ends of the can are firmly bulged out, and no matter how hard you press, you can't dent them. This often happens because of a chemical reaction inside. If the food is acidic like tomatoes, it reacts with the iron in the can, and it can produce hydrogen gas, which builds up a lot of pressure. So from the springer, try to picture out a seesaw. If you do a seesaw, the one end of the can is bulged out. If you push on that bulge end, so the opposite end will pop out. So this tells us that there's a moderate amount of extra pressure inside the can. So for the flipper, it is if you tap on one end, the other end will suddenly bulge out or flips out. Then if you press on that bulge end, it will pop back in, or it flips in, and the other end will flatten again. So this is usually means there wasn't enough vacuum created inside the can when it was sealed. So the slight pressure inside is enough to make the ends pop with a little force. So that is a little background for this for defects, but it is just one. These are terms that describe serious container defects characterized by can ends that are distended or bulged to varying degrees. So these conditions necessitate immediate attention and thorough investigation to determine the underlying cause. Unless testing proves otherwise, any can exhibiting this characteristic must be treated as a serious defect. So this distension of the can ends can be attributed to several factors, including overfilling the can or a failure to achieve a proper vacuum during the sealing process, biological factors such as microbial spoilage with gas production resulting from under-processing, or post-process contamination can also lead to this issue. Furthermore, chemical reaction within the can such as microbial gas production during the time lag between closing and processing, or hydrogen gas production from the interaction of the product with the metal plate can cause swelling. Those that I mentioned earlier, the soft swell and the hard swell. The picture here is an example of the overfill, so it shows that the cans are bulging. So now we are here in the handling defects. Refers to flaws or damage that occur to a product or its packaging as a result of the way it is moved, stored, or otherwise handled by the people or equipment, a direct result of those. One of the example of the handling defects is the crash. It is considered as a serious container defect characterized by extreme mechanical deformation of the metal container, as what you've seen here in the picture. The can is in severe deformation, so it looks like a trash already. So this significant damage can occur due to a misfeed of the filled can in conveying equipment during the manufacturing or handling process, or as a result of transit damage during shipping and distribution. So the severe distortion of the can compromises its structural integrity and, most importantly, its hermetic seal, which is essential for preserving the safety and quality of the contents. A crash can may lead to leakage, spoilage, and potential contamination, rendering the product unsafe for consumption. Therefore, identifying and removing crash cans from the supply chain is crucial, and measures should be implemented to prevent such damage during handling and transportation. Another handling defects is the punctured. It is classified as a serious container defect involving the complete penetration through the metal plate of the can body or end by a sharp object. This breach in the can's structure results in a loss of hermeticity, meaning the airtight seal is broken. So its common sources of this defect include contact with sharp corners of equipment during handling, sharp objects like staples, cuts, or gashes from knives or similar tools, and punctures caused by forks of lift trucks. The loss of the hermetic seal comprises the sterility and safety of the can's contents, potentially leading to spoilage and contamination. Therefore, punctured cans must be treated as a critical defect and removed from the supply chain to protect consumer safety. Preventing punctures requires careful handling procedures and measures to minimize contact with sharp objects throughout the manufacturing, handling, and transportation processes. Last but not the least of the handling defects is the scored. A scored can end or body is considered a serious can handling defect. Scoring is characterized by a sharp, linear stressing or deformation of the metal plate. This damage can be severe enough to cause an actual fracture or failure of the metal. Even if the metal isn't immediately fractured, a score creates a weakened area that has the potential for future failure due to corrosion or stress from normal handling during distribution and by the consumer. The common source of this defect is deep scratching of the metal plate surface, which can occur on either the inside or the outside of the container. Because scoring compromises the structural integrity and the protective barrier of the can, increasing the risk of leakage and contamination. It is classified as a serious defect requiring removal from the supply chain, and preventing scoring necessitates careful handling practices to avoid abrasive contact with the can surface. All in all the defects that are mentioned earlier is a significant importance because it is directly addresses factors critical to the safety, quality, and overall success of the canned goods industry. A primary concern is ensuring food safety, as many defects such as punctures or crushed cans compromise the can's hermetic seal, which is essentially for preventing microbial contamination and food spoilage. Maintaining product quality is also vital, as defects like paneling or coating issues can negatively affect the can's appearance and the consumer's perceptions. Furthermore, by identifying and mitigating the causes of these defects, manufacturers can reduce waste, improve production efficiency, protect their brand's reputation, and comply with food packaging regulations. That's all. Thank you.